Okay. Maybe I should record in your class, and you guys would have to be quieter. Right? Okay. So yesterday we talked about Ferris wheels, right? And how they create the rotation of a Ferris wheel creates a sine wave. We're just going to take it a little bit further today. And we're going to start, my whole purpose of today is to just get you familiar with a unit circle and where degrees are inside of a unit circle. Okay? So let's start that now with a little bit of vocabulary. So we talked about the amplitude, which is how high our wave is, and the midline is the middle, and the period is the distance. We're not going to use any of that today, but that's vocabulary for later on, all right? Then we talked about the coordinate plane versus the polar plane, which we're not really going to use any of that today either. It's just kind of getting you familiar with the vocabulary of trigonometric functions. This is what we're going to use today. All right, so we have our polar axis. Remember I told you I was going to find out whether our polar axis was all the way across or just here? It is just here. Here's our polar axis right there. It's a fixed line from which we measure. We always start here. Whether we're going in the positive direction or whether we're going in the negative direction, we always start at our polar axis. Okay? Then, our standard position. Standard position is any angle that starts here. So this angle is in standard position. This angle is also in standard position. It's just a negative angle. Okay? So this one's standard position, this one's standard position. They both are because they're starting from the polar axis. Yes, Princess. That's what I just said. I said I did research it, and it's not all the way across. It's just right there. It's the positive part of the x-axis. This is the negative part of the x-axis, right? So it's the positive part is the polar axis. I did double check. Yes.
So the standard position has to stay on that side of the line?
Nope. I could have one here. I could have an angle over here. It's a good question. I could have an angle that starts here. My initial ray is here, and it goes over here. I could have an angle like that, but it has to start over there. Okay? All right. Terminal ray is the beginning, where it starts. I'm sorry, initial ray is where it starts. Terminal ray is where it ends. Finally, I'm going to add one more vocabulary word in here. I'm going to add in co-terminal. Co-terminal means ending at the same spot, right? Because terminal means ending. So ending in same location is co-terminal. All right, so let's use it. All right, so it says sketch the indicated angle. We're just sketching. We're getting a rough idea of where it is. It doesn't have to be perfect. Okay, so we're going to sketch the indicated angle of rotation in standard position. So standard position means that we're starting here on our polar axis, right? So I want a positive angle co-terminal to 120. All right. So my first step is to just sketch 120. Okay? 120. If this is 90 and this is 180, right? 120 is going to be somewhere around here. Correct? This angle, this is how we draw it, is 120 degrees. I want an angle that's co-terminal with that angle, but it has to be positive. I could have an angle that's going in the negative direction. That would be right here. It would be coterminal if I went backwards, right? They would end in the same spot. But it says positive. I need a positive angle. So the only way to get a positive angle that's coterminal with 120 is to go all the way around my circle, 360 degrees, and then more, and then 120 more. Does that make sense? So my angle has to start here, and it has to go all the way around 360 degrees and then 120 degrees more. So it would be 360 plus 120 degrees equals 480 degrees. Yes, Christian. Yeah, but it says positive. It has to be positive. It can't be a negative. Yes, Blake. Yep. We're going to do negative next. Okay, so this is where the last class, I think, struggled. They see negative angle coterminal to 280, and they went negative 280 degrees. That doesn't say negative 280 degrees. It says 280 degrees, and then we're going to have a negative angle meet it there. So 280 degrees. I've got 90, 180. It's counting, it's by nines, right? 9 times 1 is 9. 9 times 2 is 18, 180. 9 times 3 is 27. 200, Matthew. Don't close your eyes. Okay, so 90, 180, 270, I can't help it. Okay, so if this is 90, 180, 270, it's just going to be a little bit more, right? That's going to be 280 degrees. 280 degrees. So I need a negative angle that's going to end there, coterminal. So my negative angle is going to start here, and it's going to go to here, coterminal. So it's just 360 minus 280. You could look at it that way. 360 minus 280 equals what? It would be a negative 80-degree angle. Okay, there's another way to look at it, make sense of it, right? If this is 280, right, and 280 is 10 degrees further than 270, and this is a 90-degree angle, then isn't it 90 degrees minus 10? Do you know what I'm saying? There's different ways to look at it, because it's going backwards. This is a negative angle. When it goes backwards, it's negative. Well, if you really wanted it to, it would be negative 360 plus 280.
Oh, it's negative because it's on the negative side. Oh.
No, not because it's on the negative side, because we went back. We went clockwise. That's what makes it negative. We went clockwise. Yes.
Do they have this in the Roberts?
What do you mean?
Did you say like the coterminal was like?
Well, it's like that's where I know where to end. I'm going to end in the same spot. You need to see it again. Okay. Not right now. This isn't a good time to go get water. Okay. So, a positive angle, coterminal with 45. So what's my first step? Draw my 45-degree angle. So my 45, do you see why this exercise is basically getting you guys used to where the angles are on it, right? That's the only point of it. But for some reason, it gets everybody's is struggling with it. Okay, so 45 degrees is in between, it's right dead in between 0 and 90. So it's right there. So here's my first angle. This is a 45 degree angle. I need a positive, means I have to go in this direction, right? This direction, I have to go positive, and it has to end here. So if I were to end here, I would have 45 degrees. That's the same angle. I need another angle that ends there. So aren't I going to have to go all the way around? So I'm going to have to go all the way around, and then I'm going to end there. Could I go all the way around again? If I really wanted to, I could go around as many times as I want as long as I end there. Right? So I've got 360 plus 45 equals 405. You guys want to try one?
Yeah.
Okay. So I was going to go to the next thing, but let's try one. $22, $23. Okay, let's try one. Why don't you guys sketch me a negative angle coterminal with thank you with 135 degrees. She gave me a coterminal angle that's negative, right? A negative coterminal angle to 135 degrees. Bing. Okay, so our first angle, the first thing we're going to draw, lathe. Oh, you're explaining it? Thank you. So the first thing I'm going to draw is my 135, so I know 135 is between 90 and 180. It's actually right in between it. So there's my first angle. That's 135. And I want a coterminal angle that's negative. So I just go in the negative direction until I get there. So that angle is 180, right, plus 45 more? That's one way to look at it. It's what? You'd have to go all the way around. So I would take 360 and I would subtract 135, which equals 225, but it's a negative angle. Negative 225, yes. Okay, so what I told you guys, what angles did I tell you we're going to be concentrating on? 30, 45, 60, and 90. I know, because I've done this a lot, I know that 135 is right in between 90 and 180, and you guys are going to know that too. It's like one of our benchmark ones, and I know that if this is right in the middle, then I know that this is 45 and this is 45. So I purposely picked something I knew in my head. Does that make sense? Yeah. Yep. Okay. Jonathan, I could have also done that by thinking to myself, how far is it to get from 135 to 180? It's 45 degrees to get there. You got to be right in the middle to do that. Yes. Yep. That's it. All right. I'm going to move on to the next piece. Okay, and then we're going to be done. Yes, already. Okay, so don't get too caught up in this vocabulary. The reason we're going to call it angle theta and angle alpha, it doesn't really matter what you call them. They're just two different angles. Okay, but in vocabulary, in mathematics, that's what we call them. We call them theta, and if it's an angle that's complementing another angle, we call that one alpha. I know, they are. Okay, so check this out. Theta is my first angle. It's the angle that's in standard position, okay? My alpha, the one that complements it, is the reference angle. All right, so I'm just going to show you what that looks like right now. All right? Okay, this is where everybody was getting confused. This is about the most important part of this lesson. All right? Because this is where we're going. Okay. All I care about right now, all we're going to be doing is we're going to be dealing with reference angles. The only reference angles we're going to be working with is, guess which ones? 30, 45, 60, and 90, right? Those are the reference angles we're going to be dealing with. Today, we're going to deal with more because I'm just trying to get you used to the unit circle, okay? But those are the ones that we're going to be, that's why I picked, Jonathan, that's why I picked 135, because it had a reference angle of 45. All right? Okay, so this is how we do this. I'm going to draw my theta. My theta is 100, so that's 90 degrees plus 10 more, right? Correct? So that is my theta. So theta equals 100 degrees. I want the distance back to the x-axis. What is the shortest distance back to the x-axis? It's right here. Right? Isn't that the shortest distance back to the x-axis? So this is alpha. And since it was 10 degrees here, this must be 80 degrees? Right? Okay, let's try another one. 200 degrees. So I'm going to go 200 degrees. 200 degrees is going to be 180 plus how much more? 20. So 20 is my reference angle. That's the shortest distance back to the x-axis. What if it's here? If it's 90, then 90 is my reference angle. You still have to get back to the x-axis. It'd be 45. Yeah. Yeah, you got it?
Yeah.
If it's right in the middle, then you know it's a 45. Okay, so this angle here is theta, and theta was 200. One more? Negative 300. So I'm going to go negative 270 plus 30. So if I went 30, isn't it going to be 60 here? So my reference angle is going to be 60. Yep. You don't have to write it, but I'll know that you know that that's the reference angle. So your reference angle is never going to be negative because I'm just measuring how it's a measurement. It's not an angle, it's a measurement. Okay? Can you guys tell me this one? Oh, I don't have another one. Are you guys ready for the worksheet?
Yes.
Okay.